Hello and welcome. In this video, we're going to be discussing how to solve a word problem involving ratios. So before we begin with this problem, I just want to review some information that ratios convey. So a ratio is just a comparison of numbers in the multiplication or division sense. So if we look at a specific example, suppose I have a ratio of 2 boys to 3 girls. What that tells me is that for every 2 boys, I've got 3 girls. And let's say this is a classroom setting. So for every 2 boys in my class, I have 3 girls. Or I could say for every 3 girls in my class, I have 2 boys. So one way to write a ratio is actually as a fraction. So I've got 2 boys for every 3 girls. But one of the things that ratios don't tell us is how many students I have in my classroom. So I don't have to have specifically 3 girls. It just means that for every 3 girls, I have 2 boys. So imagine, for example, that I don't have 3 girls. Imagine I have 9 girls. Well, that's fine. It's just that the number of boys that I have then is determined because when I look at the ratio of boys to girls, when I write that as a fraction, it has to come out as 2 to 3, or 2 over 3. So if I have 9 girls in my class, one way to figure out the number of boys is to figure out, okay, well, what did I multiply the bottom by to get to 9? And here it would have been 3. So that must mean that I had 6 boys in my class. So notice if I simplify the fraction 6 over 9, again, I'm down to 2 over 3. So one limitation of ratios is that it doesn't really tell you how many total students you can have. It just tells you however many students you have, they have to stay within the ratio that's set. So if I have 9 girls, I have to have 6 boys in order to maintain the 2 over 3 ratio, or 2 to 3 ratio. Okay, same thing would be true. I could flip that around. I could write the fraction as 3 girls over 2 boys. And again, it doesn't tell me how many boys or girls I have. It just tells me that they have to stay equivalent to that fraction. So I might have, for example, 4 boys in my class, which would mean I would have to have 6 girls in order to preserve the ratio. Okay, the other thing that I want to point out that's a little bit sneaky about ratios is that there's a third piece of information that's conveyed by combining your first 2 pieces of information. So if I have 2 boys to every 3 girls, really that means that for every 5 kids in my classroom, if I combine the 2 and the 3, 2 of those 5 kids are boys. Or another way to say that is for every 5 kids in the class, 3 of those kids are girls. Okay, the other thing I want to point out is suppose I have 2 fractions that are equivalent to each other, 1/2 and 2/4. And suppose I know that they're equivalent to each other. So in this case, 1 over 2, hopefully you agree with me, is the same as 2 over 4. Well, if I know the 2 fractions are equivalent, then I also know their cross products are equal to each other as well. So 1 times 4 has to be equal to 2 times 2. So we're going to use these 2 ideas to help us solve the problem involving ratios. So here we go. If the ratio of yes votes to no votes is 4 to 7, and if there were 6356 no votes, what was the total number of votes? So a lot of times when I'm doing word problems, I start with the question part, which actually really kind of begins with this if. If there were 6356 no votes, what was the total number of votes? So what I want you to notice is that no votes is being linked to total votes. So it would be nice if I could write a ratio of no votes to total votes. So if you look at what we have initially, it says that for every 4 yeses, we have 7 no's. What that means, if we combine those 2 pieces of information, is that for every 11 votes total, 7 of those votes are no votes. So now I know that my no votes to total has to stay within the 7 to 11 ratio. So then on the other side, if I know that I have 6356 no votes, my job is just to figure out what the bottom number is. So since I don't know it right now, I'm going to call it X. And now I'm going to use the idea that if these two fractions are equal, and they really have to be, because I know that however many no votes I have, the number of total votes is going to make this fraction equivalent to this fraction, or has to stay true, to this ratio. So what I'm going to do is use cross products to help me. So I'm going to multiply these two guys together. So 7 times x is 7x. And I know that that has to equal these two guys multiplied together. So 11 times 6356. Okay, if we use a calculator for that, we end up with 7x on this side. On the other side, we end up with 69,916. Okay, then all I need to do from here is solve for x. So divide both sides by 7. So if I divide both sides by 7, I'm left with x equals 9988, and again, that represented my total votes. Okay, so here's another one for you to try. Pause the video and then restart it after you've given it a shot. Okay, so if we begin with the question part, it says, if there are 184 total people, how many men were there? So what we're linking together are total people and men. So it'd be nice to have a ratio of total people to men, or men to total people. So what we know from the given information is that for every 3 men, there are 5 women. So that means I can write a ratio of men to total people, because I know that if I combine those two together, that for every 8 total people, there are 3 men. And so what we know is that there are 184 total, and what we don't know is how many men we have. So I'm going to call that x. And now we're going to use cross products to help us solve this. So 8 times x is 8x, and that has to equal 3 times 184. Three times 184 is 552. And then all we need to do is get x alone from here, so let's divide both sides by 8. And from there, we end up with x equals 69. And remember, that represented the total number of men.